good morning, good morning, good morning. So, today we're going to be out of the blue packet, and then we will, we won't obviously get through all of it today, but we'll pick up more of it on Tuesday. We have our 4-mod class. Okay? So, yesterday we were talking about exponential functions, and exponential growth functions, and exponential decay functions, and we said that if we looked at the b value, so here's our b value there, and then there's our b value there. If we look at those b values, that's going to determine whether it's an exponential growth or an exponential decay. Okay? Growth obviously going up as we go to the right, decay going down as we go to the right. Okay? But truly in math, and because the goofy rules of, the b value being between 0 and 1 and bigger than 1 and all that fun stuff. So we need to come up with something easier, okay? And E is that easier aspect to it. So in higher levels of math, base E is primarily used in exponential growth and decay. It's a both kind of a situation. It's for exponential growth and exponential decay. The number E came to the importance in the 1600s with Napier's work on logarithms, as well as Bernoulli's work on continuous compounded interest. And so the true, up here in the corner, and actually it's up in the corner of your page too, okay, the true definition of E is it's the limit as x goes to infinity, so as x gets bigger and bigger and bigger, of the quantity 1 plus 1 over x to the x power. And that's E. Now, we like E as a number, or E is a number, and that number is 2.71828 189 something. I had it out for a while. E. Is that it? Yeah. That's fine. You have to keep putting it in. Okay, keep putting that. Well, there it is. E. Enter. 2.718281828. 9 something. Okay? Alright. So let's graph it. Okay? So if we think about e to the x power, so if I'm thinking about here of f of x as e to the x power, well, that's really 2.71828 to the x power. What can you tell me from yesterday about that function, or about that graph of that function? Why is it a growth? Because the b value is bigger than 1. Yeah, exactly. Okay, what else? What other aspects of that can you tell me? Aspects of that function can you tell me? From yesterday. Things we talked about yesterday. What do you got? Horizontal asymptote. Yep. I had what you meant, but yeah. Yep. Horizontal asymptote. Okay, so it's got a horizontal asymptote of y equals 0. We said it was a growth. What else?
Is the y-intercept
0, 1 is the y-intercept. What's one more key point that it goes through? That's just a number, though. I need it in point. 1. It also goes through the point 1, 2.71828, or 1, e. Okay? So if we were to graph that function, like that, right? Okay, love it. Okay. So if E is constant, then we can't change the rate, okay? Or we can't change that B value. We have to change something else in it to make it be a growth or a decay. Okay? So exponential functions that have base E have the general form of f of x equals a times e to the kx power. Where the rate of growth or decay is controlled by the variable k. Okay. So if we just take a out of it, well, let's just say a is 1, because all that a would do would be adjust our rate of growth, or our speed of growth, I should say, or speed of decay. Okay. So if it's a growth function, which we just had before, if this is a growth function, looks like that, k is going to be greater than 0.
Is that just what it is? Or is there a reason for that?
Because then the exponent is positive. And then you have a growth, because you got 2.71. You've got a base with a positive exponent growing all the time. Yeah. If it's a decay, k is less than 0. Don't have to think about, well, is this a fraction? Yes, the b is in fraction form, but is that fraction bigger than 1, or is that fraction less than 1? Is all all this? It's positive and negative. Okay, that's what makes it nice. Because now, if k is negative, then 2.71 to a negative power, we would reciprocate that 2.71. So we'd have 1 over 2.71, and then it would be have a positive exponent. Okay, so that's what makes it a decay there. Right? Okay? So k being positive or negative tells me if it grows or if it decays or whatever's going on with it. Okay? So let's compare the two forms, yesterday and today. Okay? So yesterday, if it was a growth function, we said that b had to be bigger than 1. Today, we're just saying k has to be positive. Oops, today. Wrong color. Yesterday, if it was a decay function, we had a range. Today, we're just saying k's got to be negative. In word form, okay, my exponential function is of yesterday, so the first one is yesterday's. Then the rate of growth or decay is controlled by the value of b. If b is greater than 1, then the function is growth. And if b is between 0 and 1, then it's a decay. And today we're saying, let's make that even simpler. If k is positive, it's a growth. And if k is negative, it is a decay. We should put is in there. That's a true sentence. Otherwise, my English teaching friends would yell at me. Let's sketch this one. First off, just from inspection, left one on the bottom of your page. What can you tell me about this one? Talking about
It's a growth.
why is it a growth?
Because the k value is greater than 0.
Love it. Love every part of that. This is a growth. Because k is greater than 0. Okay? What else can you tell me about this one? What do you got?
It's horizontal since it's at
Y equals 0. Why is it horizontal less than y equals 0?
because there's no like added number at the end.
Yep, exactly. There's nothing back here to shift that graph. Okay? Just like yesterday, actually let me go back a slide here and then let me add this one in. Just like yesterday we said that if we had, it was f of x equals a times b to the x minus c, then plus d type of a function, where c shifted it horizontally and a or d shifted it vertically. Okay? So today, that would be f of x equals a times e to the x minus c plus d. Oops, I forgot k in there. Okay? So that would be today, where same thing happens. C is going to shift it opposite thinking. C will shift it horizontally, and D will shift it vertically.
Is the intercept at 0, 4? Because 4 is
Let me get it back up to speed. So you're saying that the y-intercept is at 0, 4? Do we agree with that?
I agree with it, but it's also kind of confusing. Because you said the D moves it up and down. So if the y-intercept is moved up forward, wouldn't the A be moving it up and down?
No. No.
So what does it do?
It stretches it vertically. Same as it, like yesterday we said, it makes it grow a little faster, or it slows down the growth a little bit. Yeah, it's a stretch. It's not a shift. Yeah. Okay. All right. So we're going back to, so then everybody agree with 0, 4 because of the 0, a. Plugging in 0. Okay, you plug in 0. 0.5 times 0 is 0. E to the 0, anything to the 0 power is 1 times 4 is 4. Love it. Okay. And then now, yesterday we talked about plugging in 1 then. Have your exponent equal 1. Okay? Well, what value of x would give me an exponent equal to 1? 2. So I'm not going to plug in 1 here for x. I'm going to plug in 2. Okay? Because 0.5 times 2 is 1. So that gives me e to the first power, which is roughly 2.7. Okay? And 2.7 times 4 is what? 10.8-ish? You know, we don't have to be exact. I mean, we can definitely go to a calculator if we wanted to be exact, but we're roughly in that 10.8-ish aspect of things. So that be somewhere like right in about there. And so then, Aaliyah, back to your point, it makes it grow quicker. Okay? Because we're growing at a faster rate because of that A value. It stretched it. We grabbed onto it. We stretched it out vertically. Okay? All right? With me? Love every part of that. Okay? So what I'd like you to do now is I would like you to try example number 2. What can you tell me about example number 2? What you got? It's a decay. Why? Somebody other than Liz, why is it a decay?
Because the K value is negative.
K value is negative. Yep. Okay. What else we got? What you got, Cordy?
The horizontal asymptote at y equals 1.
Y equals 1 because we have added something after it. Okay. Love it. Key points. Talk to me.
The y-intercept is at
15.
15.
Oops. Blue. I should say that was black, not blue. Y-intercept is at 0, 15. Okay, so that's way up top. Okay. Plug in 0. Get 15. Love it. Okay. Another key point. TK, what'd you use as your second point?
I plugged in negative half
Negative a half. Okay.
for x.
Okay, for x, and then that gave you a value of 1 for an exponent. Okay, all right, and you should have gotten a pretty large number, I would think, right? What'd you come up with?
I used 2.7, so
Okay, that's fine.
I got 38.8.
38.8. So that would be like way up here. Okay, anybody use a different one? Different point? To make that 1? No? Well, maybe not 1 necessarily. What could have we used? Actually used 1, and gotten negative 2, right? Okay, and then type that one in on our calculator, okay? Or really any other point too. We could have done any other point. Okay, so if we would have chose, oops, I'm gonna make my t-chart down here. So if we choose 1, just as 1, so then we got e to the negative 2 power times 14. Somebody with a calculator, e to the negative 2 times 14. So I would go on yours, I would go e is the second of that one, and then go negative 2, and then hit enter, and then times 14. 1.8, or 1.9-ish. Then plus 1 would be like 2.9-ish. You know what I mean? Okay. Or we could have done 2 or 3 or something like that. Okay. Either way, we know it's going to be a decay, so it's going to come down through here. Oops, I'm going to miss that. And go there. Yep. Love it. If you could dig out yesterday's, I just want to quickly go over, because we've got some spare time, quickly go over what those 6 graphs should have looked like on the top of the back side of the page. So number 1 should have looked like a growth where you went through the points, actually we'll switch colors here, where you went through the point 0, 3, and 1 comma 6. Should have had a, actually all of them should have had a y-intercept of, or not a y-intercept, excuse me, a horizontal asymptote of y equals 0. Okay, on all of them. Second one should have looked like went through the point 0 comma 4/3 and 1 comma 4. Third one should have been a decay. And so it should have gone through 0 comma 6 and 1 comma 2, or I would have also accepted their negative 1 comma 18. Fourth one yesterday should have looked like this. Growth going through negative 2 comma 1 and, oops, didn't really draw this one the best, 0 comma 16. Decay for number 5 should have gone through 0 comma 8 and 1 comma 2. And the last one. Now the last one, growth or decay on this last one? Why decay?
Because the x value or the exponent is negative.
So that means we got to reciprocate the b value. So the b value there was actually 1/2. Yeah. And so then this one looks like this. So it's a decay going through 0 comma 10 and 1 comma 5. Okay. Okay. That's all I got for you today. Thanks for playing along. What's up?
It's a
Okay. Oops. Gotta put that down first.